Here we have LeRoy's IC-7300, and he sent it in to install the Asymod 7 internally. In this video, we're going to go ahead and walk you through the installation of the Asymod 7, which should be fairly similar to the Asymod Mini. I've been getting a lot of requests for installation instructions on the IC-7300. And despite all the information and text and manuals, folks are still having trouble installing the Asymod and multiband HF radios. So we're hoping that after this video, it could walk you through the installation process without any issues. First thing we do is we connect the radio and try it out in all modes, check out power output and reception. Then we go ahead and take off all the screws from the top and bottom cover. Once we take off the top cover, we're going to remove the speaker, unsolder the wires, and tape the wires in case we have an accidental short. We don't short out the audio output amplifier. And this particular unit has the pen adapter installed. Carefully flip the speaker over and remove the two wires. We have now removed the speaker and put tape on our audio wires to avoid any shorts. Next, we'll go ahead and remove the pen adapter. In this particular unit, they've already installed the ALC cap. It's a 4.7 microfarad capacitor. We're going to remove that and replace it with two 10 microfarad electrolytic capacitors in parallel, making it 20 microfarads. We have now removed both bottom and top covers. And we're going to remove now the front panel. Remove the 4 screws that hold in place the front panel and lift up and remove J421. We're going to replace the two 10 microfarad parallel caps with one 22 microfarad capacitor, and here's our 47k ohm resistor, which will be used for the AGC suppression. Now that we've installed our ALC cap, we're going to go ahead and install our transmit AGC suppression with this 47k ohm resistor from pin number 9 of this IC to ground. You should use something like the Kessler 951 no clean flux to avoid shorting out any of the pins on that IC. As you can see, they're pretty close, and it's not easy to get it done the first time right. Next, we're going to move over to the PA section, and we're going to come right here, and we're going to remove this inductor right here, that guy right there. I've now removed the inductor, as you can see right there, and there it is, removed. So we have those two solder pads. Next thing we're going to do is we're going to connect to each of those solder pads a wire, and that's going to be our modulation output from the Asymod and the final VCC into the Asymod board, which will be located on J2 pins 4 and 5, which are the green and black cables seen here. From right to left is a green and blue cable. The green cable is the final VCC, and the blue cable is the modulation output from the Asymod board. So, on this board, over here, the left solder pad is our final VCC, and our right solder pad is our modulation input. So on the left, which is our final VCC, we will have pin 5 connected to it, which is the green cable, and the blue cable will go to the right side, the right solder pad, which is our modulation output from the Asymod. By the way, we're going to have to connect a 22 microhenry 1/8 watt or 1/4 watt inductor in series with the wire coming from the modulation output of the Asymod to this right solder pad right here. First solder end, our final VCC green wire to the left solder pad as seen there. We'll first ready our blue cable modulation output cable and install in series our 22 Henry 8th watt 22 microhenry inductor. We have now soldered the modulation output blue wire to the right solder pad. Next, we'll shrink wrap our inductor so it looks like this and we avoid any shorts. Next, we'll put a dab of hot glue in between the connector and the RF connector to hold those two wires in place to avoid any vibrations that might disconnect our connection to our pads. And run the two wires through this opening to the other side. Next, we'll prep our line end connector with this Marshall type 1/4 inch connector. It's an interrupted type. Then we're going to cut two pieces of RG174, one about 12 inches long, the other one about 15 inches long. The shorter one will go to the Asymod input from the uninterrupted pin of the 1/4 inch jack. The longer one will go to the audio output of the radio's preamp to the interrupted pin of the 1/4 inch connector. First thing we do is we gotta prep the connector. We gotta cut those two end tabs and shave off one of the sides so it could fit properly next to the other connector. We have now shaved off both sides of the connector. It looks a lot slimmer and it's gonna sit upside down. Next, we place the connector in the position where it's going to be. We mark the position of the hole and we make an indentation with our punch so we could drill precisely. The Marshall type 1/4 inch jack should fit snug into the hole and look like this. Next, score the PC board, take off the silk screen in that area and solder a copper plate behind the 1/4 inch jack to avoid any vibrations moving it. Prep both our G174 audio cables with the ends nicely terminated with heat shrink. The shorter cable will go from the unswitched pin on the 1/4 inch jack connector to the Asymod. The longer connector will go from the switched interrupted pin and the 1/4 inch connector to the Asymod enable disable switch. First, we solder in the short cable, which will go to the Asymod line N, and this is the unswitched pin in the back right, and the ground is the center there in the front. Next, the longer cable that goes to the Asymod enable disable switch. Next, we'll put some shrink wrap to keep both cables together. We'll then guide the shorter cable through this opening and guide the longer cable to the Asymod enable disable switch through this opening. Bring them out to the other side as seen here and guide this one to the back under these cables. It's going to go around right here. Solder to ground here and to the switch over here. This one will go to the Asymod board underneath it. We've now routed the rear cable that goes into the Asymod enable disable switch underneath those cables there, and as you can see, it's right here. Take note that this is the AM active high 3 volts that goes connected to the Asymod remote input. It turns on the Asymod for the AM mode and it turns it off and it puts it into sideband mode. And it also triggers the RF finals VCC switch, logic high or low. And this here, this location, is also wrong in some of the manuals and is supposed to be in the collector of this transistor. So make note of that. Right in that position, the collector right there. That is your TX 8 volts, which triggers the amp keyer. Next, we'll install a red cable and we'll solder it to the collector of this transistor right here, right there. That's going to be our 8 volts TX coming from pin 2 of J2 right here. The red cable right here. And here we have our TX 8 volts soldered to the collector of the transistor right there. Next, we'll connect the AM active high signal to pin 1 of this IC right here. That will go to our remote to turn on our Asymod while on AM mode. Route both wires, heat shrink them, bend it, and put them down to the other side. Next, we connect our power wire. We connect it right here. And we route it around, and we pass it to the other side. Flip the radio over, and now we're going to make the holes for the amp keyer and the Asymod enable disable switch. And here we have both holes, one for the Asymod enable disable switch and the other one for the amp keyer. And we'll go ahead and install both of those right now. We've now installed both the switch and the RCA jack. Now we're going to put a 104 or 0.1 microfarad capacitor across the RCA jack. We'll now go ahead and remove this capacitor. We have now removed the capacitor, and as you can see, we have the 2 solder pads right there. We now prepare a short cable with a 2.2 microfarad monolithic ceramic cap in series, or a 225. Put heat shrink tubing to one side of the cap and run a short piece of wire to the right side solder pad. Connect another piece of short wire to the other solder pad. Connect the wire coming from the right solder pad via the capacitor to the bottom center pin of the DP/DT switch. Connect the long wire of the same color to the left wire coming from the left solder pad. Put them together and add some heat shrink. Next, connect the 2 wires to the bottom left pin of the DP/DT switch. And route the longer side of the wire to the Asymod position, where the Asymod will be installed. Next, we'll connect our audio coax coming from the interrupted side of our 1/4-inch jack to the bottom right pin of the DP/DT switch. And here we have our coax connected to the bottom right pin of our switch and to the ground on the can. Next, we connect the active high AM signal from this orange wire that came from the other side of the board, and we previously installed it to one of the ICs, to the center top pin of the DP/DT switch. Solder another orange cable from the top right pin of the DP/DT switch, and we route it to the Asymod board's position. Next, we connect a 600 volt rated flexible cable to the amp keyer jack and run it to the Asymod's position. Next, we solder our ground wire right there to that screw on the collar of the hole on the PC board itself. Now we'll move on to prepping our Asymod 7 board. Remove one board from the breakout panel and install the DC to DC up converter. We have now installed the DC to DC up converter, and we'll move on to the rest of the components needed to modify the board to work with the IC-7300. Here we can see the mods that need to be done to the Asymod 7 to properly work with the IC-7300. We'll first install an update that is not in the documentation, and it's installing this 0.1 microfarad capacitor, or a 104. It's a ceramic monolithic in that position. We've now installed all of the necessary components to match the Asymod to the IC-7300. Take the MJE 3055, cut the top, solder it in place, and place heat shrink tubing over it. We'll now prep the potentiometer harness cable with a multi-core cable. Now prep the multi-core cable for the potentiometers. We use the red and orange for the modulation, black and white for the carrier, and blue and green for the asymmetry. The rest, brown, purple, gray, and ground shield to ground. We finish installing the potentiometer harness. We now have the Asymod board ready to mount on the IC-7300. Now drill the hole for the potentiometer harness, and that hole is going to go right in that corner. So we've already drilled the hole for the potentiometer harness, and now we'll flip the radio over, and we're going to be ready to start mounting the Asymod right in its location right there. We have to put all the ribbon cables in the down position rather than the up Z position that they come from factory to allow for the Asymod to fit properly. We now bring all the cables to the Asymod position in a harness. We put some shrink tubing right there, and now we scribe the holes to mount the Asymod 7. So now here are the mounting holes for the Asymod. We are now ready to connect all the wires to the Asymod 7 board. In this install, we've decided to use the potentiometer wire harness directly soldered to the same spot where the normal potentiometers are mounted, instead of J1. As you can see, you have the option to use the connector J1 to run your wires for your potentiometers. So we now have mounted the Asymod, and for the modulation out and final VCC, we've used J2, but we did not use J1 for the potentiometer harness. We connected the harness directly to the onboard pot locations instead. We routed the cable, the harness for the pots through the hole. And now we're gonna prepare the top panel with the potentiometers. But before we do that, we're going to mount our PTT jack, our 1/8 inch mono connector on the rear chassis for the PTT mouse or PTT switch or PTT foot pedal. Here we have the PTT 1/8 inch jack with a 104 or 0.1 microfarad ceramic capacitor across the input. And here is the PTT jack mounted on the rear chassis, and the cable has been run along the side to come out through the front. And it's going to go connected to the front panel mic connector. Here we have the front panel, and this is the microphone connector. Solder a 22 microhenry inductor at this pin. Solder a 104 or a 0.1 microfarad capacitor to the pin next to it, and join both the inductor and capacitor at the top. Solder a piece of wire the same color as the one that was soldered to the PTT connector, which is brown in this case, to where the capacitor and the inductor meet. These two wires will be joined together once we attach the faceplate to the body of the radio. Now it's time to select our potentiometers. We're going to be using the VCS P16NP series sealed potentiometer, manufacturer in the Czech Republic, low profile, sealed, very good quality, not cheap. They're about $15 to $20 each. And we have here the 470 ohm is going to be for the carrier. This one's going to be the 5K ohm for the asymmetry, and this one's going to be the 10K ohm for the modulation. So we'll prepare the end of the harness so we connect it to the potentiometers once we mount it on the top cover. We have now opened our 3 holes for the 3 potentiometers on the top cover. Next, we'll attach our label and punch the holes in. We have now installed the 3 pots on the top cover. Now we'll cut an opening for the potentiometers along the top of this front panel. Attach the front panel and terminate the harness, ready for installation to the potentiometers. Now we've connected our wires to the potentiometers. Notice that the carrier, we used the 2 left pins. For the modulation, we used the 2 right pins. And for the asymmetry, we use the 2 right pins as well. Now we connect the pin adapter back and all the RF cables. And lastly, the speaker. Now we've installed the speaker back into its location. Make sure to neatly put the cables back inside so they don't touch or short out. So here we have the finished installation. So here we have the finished product. Now we've completed the installation. Over here in the rear, you have your line in, you have your PTT switch, your Asymod enable disable switch to the fan position. Asymod is enabled to the outward position. Asymod disabled. Radio operates as factory, front mic, and this is your amp keyer right there. So we'll plug it in and give it a little test run. So we've connected all the connections. So we've connected all the cables in the back. We have Pro Tools running. We're going to try with the SIGGEN on AM. Bring all your controls counterclockwise to minimum. We'll go ahead and key up. We're going to see here on the bird, as we move our carrier control, we're going to vary from 0.5 watts all the way to 22, 23 watts. As we bring it down. Okay, so we'll set it at 2 watts, right there. Okay, here we're on the 200 watt scale. We come down, it's a little off, but it should be at 2 watts. The bird says 2 watts. I trust the bird better than I do this one. Although they need to be recalibrated. It's been a while. All right, so we have the 2 watts on the bird. We'll go ahead and set our reference exactly 2 gradients or 2 divisions on the O-scope. Center that. We'll go ahead and start the SIGGEN. There we have the SIGGEN going. We see now we have the carrier starting to get modulated. We're going to lift up our modulation control, and as we lift it up, we'll reach 100% modulation right there. So actually, without any asymmetry, is doing about 103% modulation, but it's a perfect, beautiful envelope, as you can see right there. We can make that a little there. We'll leave it there. So if you want more loudness, you can bring up your asymmetry, and you'll see now we can go up to, that's 150, that's 200, 220, 225% modulation. Okay, so again, that's our 2 watts modulated at 100% gives us about 7 to 8 watts. When we increase the asymmetry, we could bring it up to 10, and at 230% modulation almost, we're doing about 16 watts out of a 2 watt carrier. All right, so there you have it. So we'll put the asymmetry about 150, 200, we'll leave it there, and we'll stop transmitting. Now the power should be set on the RF power should be set to max while operating the Asymod. Mic gain is irrelevant unless you use the front hand mic. Okay, so what we'll do is now I'll cancel the SIGGEN and open up the microphone, our RE20 here. So now we'll go ahead and transmit, and as I speak, we'll be able to monitor our modulation envelope. Audio 1, 2, 3, 4. There we see peaks of 200% modulation easily. Audio 1, 2, 3, 4. Audio 1, 2, 3, 4, 5. All right. So there's your modulation envelope. Now let's go ahead and try sideband with the processed audio. Sideband, we're on upper. We'll transmit. Audio 1, 2. Of course, the power now can be controlled through the RF power of the radio. We'll adjust this here. Audio 1, 2. Audio 1, 2, 3, 4. That's our sideband modulation envelope. And we're here on sideband audio test. Okay, so now here you can control your RF power and your mic, not your mic gain, because now we're running the Pro Tools, but your RF power can be controlled through here now. Audio 1, 2, audio 1. So at minimum, we're doing there about, let's see, let's put it in the 200 watt scale. Audio 1, 2, 1, 2, 2, about audio 1, 2, about 20 watts on minimum. And as we raise up the RF power on the radio, we easily reach 100 watts. Okay, so that's without the hand mic. Now we'll take out the line in connector, plug in the microphone, and we'll key up audio 1, 2, audio 1, 2, and obviously we have to bring up the mic gain, the RF power. We're at minimum. Audio 1, 2, 3, audio test, and there's our 100 watts using the hand mic. Okay, and at this point we still got the Asymod in line, so we're going through the Asymod. Let's go back to AM using the hand mic, using the Asymod. Go back to AM. We'll key up. We've got the 2 watts on the bird. We got to set a reference here. Right there. Audio 1, 2, audio up. You can see we still have the audio 1, 2, the 200% modulation using the hand mic, but our audio won't be as good as, or as a wideband as using the processed audio. All right, now sideband with the hand mic. Audio 1, 2, audio 1, 2. There you go. All right, so everything works perfect. The Asymod 7 and the Icom IC-7300.